Hello everyone and welcome to the Math Bender. I'm Adnan Zaidi, and in this section we'll discuss geometrical properties of circles, an extension of all the theorems that we've done so far. So let's start. Okay, so if we talk about theorem number 4, we already discussed 3 theorems before. You may want to visit the previous lectures before looking into this one. So let's say if we have a circle and a quadrilateral in it in such a manner that it's touching all of its 4 corners at the circumference. Now this quadrilateral is called a cyclic quadrilateral. Now the rule is that even if you draw them, you will observe that the angles opposite to each other. So let's say if I name this angle A, angle B, so the sum of both the angles of the opposite angles of the quadrilateral are 180 degrees. So if this is angle C and this is angle D, then C plus D is also equals to 180 degrees. So let's see some of the examples here. Now as you could see, it's a cyclic quadrilateral. All 4 corners are touching the circumference. So in order to find A is going to be 180 minus 105 because of the supplementary angle. Straight line is there. So 180 minus 105 is going to be 75. So this is 75. The angle that is opposite to it is B. So B is going to be 180 minus 75 because the sum of A and B is also 180. So hence it is also equals to 105. Now C is opposite to 72. So you can say 180 minus 72. So 180 minus 72 is going to be 108. 108. Looking at another one. Okay, so as you could see, it's a cyclic quadrilateral. 4 corners are touching the boundary of circle, but it's not as simple because I need to find out x. And as I can see that this angle here, if I'm able to find this angle, so let's look at theorem number 3. So if you look at the angle facing this green arc, so any other angle facing the same arc, as you could see that this angle is also facing the same arc connected with these 2 dots. Remember that it's not only the angle that is facing that arc, it's connected with the same dots A and B in this scenario. So this is going to be 41. Now the angle that is opposite now is going to be, now I need to find this angle as well. So if I see this angle is facing this arc, so let's highlight it. So now as I can see that it's as same as 65 because 65 is also on those 2 points C and D facing the same. So this is going to be 65. So as we know that this whole angle is opposite to this whole angle of the cyclic quadrilateral, and they all sum equals to 180. So I can say x plus 65 plus 41 plus 27 is going to be 180. So I'll subtract straight away 180 minus 65 minus 41 minus 27. So x is equals to 47. Now looking at another question here, you can see that there are two isosceles triangles, this and this. They are equal, so which means if the sides are equal, the angle is going to be as well. So this is going to be 54. So in order to find this angle, it will be 54 plus 54 is going to be 72. And in a cyclic quadrilateral, this angle is going to be 180 minus 72. So which is going to be 108. And now highlighting the other isosceles, this one and this one. As you can see the markings, so they are isosceles as well. So I can say if this is y, this is going to be y as well. So I can say y plus 108 is equals to 180 degrees. 2y is equals to 180 minus 108, which is going to be 72, and y turns out to be 72 over 2, which is equals to 36 degrees. Let's look at another theorem here. So let's say if I draw a circle and a line that just passes through at one point and does not enter the circle at this point, let's say point P. So this line here is called tangent. And this line, the radius from center O, radius, the relationship of the tangent and radius will always be a 90 degree. Not only radius, we call it at times normal to the tangent. So the relationship of these two is that it's going to be 90 degrees. So moving on to some questions here. Now, as I can see that this is the tangent and I need to find out x and y. I'll just write down the name of those theorems. So for example, so this one was 4 and this is 5. So I'll just write down the name what I'm using. You can reconcile with while looking at the lectures. So as I know that this whole thing, this whole angle is 90 because this is the diameter and hence partially radius. And in order to find this much, so I'll subtract 25 from 90. So 25, if I subtract from 90, it will be 65. Now, using theorem number 1, I can see that this is the diameter. And we already established that the angle opposite to diameter at circumference is 90 degree. So this angle is also 90 degree, out of which this portion, this small portion, is 65, so this is going to be again 25 after subtracting from 90. So I can say y is going to be 90 minus 65 using theorem 1, and this is going to be 25. Now, looking at this arc, and I can see that this arc, the angle y is facing this arc, stranded by these 2 points A and B at the circumference, and the same arc angle x is facing using the same 2 points at the center. So according to theorem 2, x is going to be 2 times 25, and hence it's going to be 50 using theorem 2. Now looking at another question here. Now the tangent line is TP. The first thing is I can see that this line, these two lines, clearly indicates that the question wants you to look for alternate or any other angles that involves parallel lines. So using this Z, as I can see that it's an alternate angle. So this is going to be 33. Now, so I can say angle O is going to be 33 because it's an alternate angle. Now, moving on with X. So this is 33. Now, after finding this 33, now look at this arc. The angle facing this arc at the center at O is this, using these 2 points. And the angle facing the same arc at the circumference is Y. So Y is going to be half of it, 33 over 2, which is theorem number 2. Now, in order to find X, I can see that this arc here is facing this angle at the center and same x at the circumference. So the same relationship as we found out for y we can use here as well, but given that we need to find that angle AOT, so I can say that it is a 90 degree because I can say that angle A is 90 degrees, theorem 5, because it's a tangent and the radius at the same time, so it's going to be 90 degrees. And then angle AOT is 180 minus 33 minus 90. So it gives you 57. So this angle here is 57, and angle X is going to be 57 over 2 using theorem 2. There are many other ways that you could cater to this question, by the way. So not only one solution that would be, I mean, I even writing while talking to you, I can think of many other solutions right now. But so approach can be anything as long as it is mathematically correct. Now there are two tangents, both emerging from point P, as you could see the first one and the next, this one, PA and PB. Now, as I can say that angle PAO is 90 degrees, the whole thing. Theorem 5. So as I can see that this is a right angle triangle. So from triangle PAO, I can find x by subtracting 180 minus 90 minus 20, which is x going to be 70. Now in order to find y, now erasing all the highlighted, because now this one is 70, and we can see that O till this point and O till A, they are radius. So this angle is equals to this angle. So in that triangle, I can say 180 minus 70, which is equals to 110. So both the angles are same, and if I divide it by 2, which gives you 55 degrees each. So this is 55 and this is 55 as well. Since this angle was 90, and if I subtract 55 from it, I will get 35 degrees. So y is going to be 35. Now moving on to some more questions. As you can see that both the tangents are emerging from the same point, and hence they are equal in length, as long as they're touching the same circle. So in order to find this, if I draw a line here, so this line is gonna bisect the angle. Bisection means equally dividing into half, because it is coming from O, the center. So this angle is 90 degree. I can say angle PAO is 90 degrees because it is of theorem 5, tangent. Now half of this is going to be 24, and I can find this much. So angle AOP is going to be 180 minus 90 minus 24. It's going to be 66. So half part is 66, so the other part is going to be as well 66. Angle AOB is going to be 132 degrees. Now for angle Y, now look at this arc. So Y is at circumference facing this arc, and at the center the same angle facing this arc is this. And how do I find that? Because I can see the whole rotation is 360, and out of which I can subtract 132. So major angle, now as you can see that I am finding angle AOB, same angle. Here it was 132, but I'm writing to identify that I'm finding out the major angle, which is facing the major arc. The other angle is also AOB, but it's a minor angle because it was facing the minor arc. Is going to be 360 minus 132. So it's going to be 228. So this is 228, and the angle that is opposite to it is going to be half of it. So angle Y is 228 over 2, 114 degrees, and the reason is, again, theorem 2. Now let's look at the last question of the day. So I have to find out CAO. So first highlight what that is. CAO is this. And if I see that, then this is an isosceles triangle. And this whole, so as I can see that since line TD is a tangent, so it is making a 90-degree angle here. So angle CAO is 90 minus 62, which is going to be 28 degrees. So this is 28 degrees. So as this. Angle AOB is this angle. In order to find this out, let's make a line here and break it. So this angle is 90, tangent making with this radius. This becomes 10, so this becomes now this angle is going to be 80 degrees, and the full is as same, so 2 times 80 degrees, which is going to be 160 degrees, and I used theorem 5. Rest was all the trigonometry that played its role. Now for angle AOC, I can find this out this much. So I'll erase. So this angle here, AOC, this one. As I know that that is 28, so I'll just simply 180 minus 28 minus again 28. It's going to be 124. There's nothing that I applied from circle theorems in it. I just found the triangle AOC, and from it I had two angles which were both equals to 28 each, and I added them and subtracted from 180 degrees. For D, it's COB. As I can see that this is also an isosceles, where this side is this side are the radii. Now I know that this angle AOB is, since angle AOB is 160 plus angle AOC, which I just found out to be 124, I add both of them and subtract from 360. So this angle is 76. And angle CBO, since it was an isosceles triangle, so this angle and this angle is going to be same. So 180 minus 76 and divide that by 2, which gives you 52. So each angle CBO is going to be 52. The reason is isosceles triangle. I hope I've made myself clear. I'll come up with some past paper questions in my next session. Until then, take care. Bye.